I welcome you all for this data science course and session 5 and 6. Okay. So in this session, we are going to look at about pandas library, in which we will be discussing about more functions which is available in pandas, which will be useful for data cleaning. Okay. So as you all know, pandas is a Python library which is especially used for working with the data sets. Okay, the data sets may be in the form of a CSV file, or maybe a JSON file, or it may be a SQL file, whatever it may be. Okay, so it has functions for analyzing, cleaning, exploring, and manipulating the data. Actually, the name pandas has been derived from two words. Okay, there are two keywords for this: panel data, and the other one is Python data analysis. Okay, so the creator of this pandas library is Wes McKinney, which was created in 2008. Okay, why you are going for pandas? Okay, so pandas is especially to deal with the data sets where you are going to make analysis on big data sets. Okay, and pandas also help you in cleaning the messy data sets and make them it will give you more clarity on the data and make them more readable and relevant. Because only if you have clarity on the data, you can do some useful analysis on the data. Okay, so pandas gives you answers like maybe some basic statistics like what is the average value, maximum value, minimum value, and what is the correlation between the data. So these kind of things the pandas can do. And pandas are also able to uh, delete the rows which is having null values, and it is also able to deal with some wrong values or wrong numbers, and it also deals with the duplicate values. Okay, the basic pre-processing on the data, the basic cleaning of the data, all these things will be done by the pandas. Okay, so the installation of the pandas is happening with the help of a command called pip install. So this is the standard command to install any package, pip install, and then you can give the library name whatever you want to install. Okay, so here I am going to use pip install pandas. So with this, the pandas library can be installed. Now let's start with how to create a small series. Series is like a row of data, or you can call it as a column of data. Okay, so this is the coding to create a simple series of data. Okay, so what we are doing here, just import pandas as pd. Pd is the short name for pandas library, and I am just creating a list. A equal to, I have 3 elements in the list, 1, 7, 2, and with this list I am trying to create a series. Okay, pd dot series, and just apply this list here. Okay, so that this list becomes a series of data. Series is just a column of data. Okay, and we are trying to print the variable that is called my variable. The my variable is a series now. Okay, now when you do this, a default index will be assigned for the series of data. Let me show you the outputs. One second. Okay, so this is what we have done. uh, so when you look at this output, you can see here there is a column of data 172. By default the index is assigned 0, 1, 2. Okay, so that is the default index. and you can get the data from the series using this kind of index. Okay, my variable of 0 means it will give you this first data, 1 means it will give you the second data, 2 means it will give you the next data. Okay, now what I am trying to do here in the next example, I can assign the index for the series. Okay, you can see here the same data is here 172 and index equal to x, y, z. Okay, so this is the index we have assigned manually. Okay, now when I try to print this data, you can see the output is something like this. Okay, 172 is my data and xyz is the index which I have assigned explicitly. Okay, that is not the default index. Okay, now when I try to get the data for this series, I will have to use this index, xyz index. Okay, so that is the way you can give index with alphabets also. It's not necessary that you have to give only the number index. Okay, this is just to show you that. Okay, now the next one, I can create a series of data with the help of a dictionary also. Okay, the example what is given here is day 1 colon 420, day 2 380 and day 3 390. Okay, which is enclosed in the curly braces. So this is nothing but a dictionary of data. Okay, color is equal to, there is a dictionary. So with this dictionary I am trying to create a series of data. So now your output will be you can see day 1 is the index, day 1, day 2, day 3 is the index, and 420, 380 and 390, these are all the values. Okay, so the dictionary has been converted into a series of data. Okay, series is nothing but just like a table of data. Okay, the next one we have, okay, data frames. Data frames you have seen already in the introduction session itself. There is a dictionary available here. You can see data equal to color is this list, and then this is duration. So with this data I am trying to create a data frame. So data frame is a table of data where you will have rows and columns. Okay, so your output will be let me run this. You can see the output here. Color is one column and duration is another column. Okay, and the index will be 0 1 2. So when I try to print the data, for example here print my variable, it prints the whole table. Okay, and my variable dot location of 1 means you can see this is the index 1. It will print the full row of data. Okay, color is 380 and duration 40. So that is the output for this second print. Okay, and the output for the third print statement is my variable dot location of 0 colon 2. It means from 0 to 2 it will print. Okay, so 0 is this and 1 2, so all the rows gets printed here. Okay, so that is the way you can access the rows from the data frame. Okay. Okay, next one we have reading a CSV file. Okay, so this example also we have seen already. There is a function called pd.readCSV. Just apply the CSV file so that the entire CSV file will go to this variable data frame. Okay, df, and then you print the df, so that will print the entire table. Okay, So if you want to print, if you want to see the full table, then you will have to use this df.toString. That will show you the full table. Otherwise, it may print the beginning 5 rows and the ending 5 rows, in case if the table is too large. Okay. Then you can read JSON file also. A JSON file is looking like a dictionary. Okay. So where you will have key value pairs, and you can read the JSON files using this kind of uh, function, read a JSON. Okay. And then give the file name. Then it will read the contents from the JSON file, and then it will give you the output. Okay. As you can see here. So this is my pd.read CSV. It's a CSV file. So let me load the CSV file first. Okay. Now the file gets loaded here, dirty data.csv. Now you try to execute this. Okay, so you are getting the output of this table. Okay. Then JSON file. JSON file is not available here, so you can load any JSON file. The JSON file will be looking like this. Okay, so that's why the dictionary is given directly here. So it looks like a dictionary of values, the data equal to. So inside this you will have duration. So under the duration, this is index 0, 1, 2, 3, 4, 5 are the index, and this is the values. Okay, the same table has been written as a dictionary, nothing else. Okay, and pulse column, you will have 0, 1, 2, 3 index, and these are all the values, and then maximum pulse, then calories. Okay, so with this it is creating the data frame, and it's showing like a tables. Okay, nothing else. So the JSON file also will be having the same content whatever displayed here. Okay, so this content will be available in JSON file. So if you read the JSON file and if you display it, it will display like this. Okay, so that is about reading a JSON file. So dictionary as JSON. So that's what I shown you this example. Okay, so this is a dictionary. Then we'll move into some basic analysis of data. So these things, what is that, head function and tail function, the info has been discussed already in the previous sessions. Okay, in the initial sessions. Okay, now in this session what we are trying to concentrate is we are trying to concentrate on cleaning of the data. Okay, so what is that cleaning? The data cleaning involves removing of the first one, empty cells, the second one, wrong format data. Okay, the data which is in the wrong format. The third one is wrong data. Okay, there is a difference between wrong data and wrong format data. Okay, and then the fourth one is duplicates. Okay, how do you handle with the duplicates? Okay, so these are all the things we are going to mainly concentrate on this session. Okay, so the sample data set we have taken already, that sample sports watch data set, right? The same data set. So let's see how to deal with empty cells. These empty cells, you can use a function called drop NA, and you can remove the null values, and you can print only the rows, which is having without null values. Okay, let me show you this drop NA already we have done in the session 1. Okay, so drop NA is to drop the rows which is having null values. So we are not going to concentrate on this. We'll move to fill NA functions. Okay, so the fill NA, instead of dropping the rows, what we are planning to do is we'll try to put some useful values into the rows. Okay, where you are having the null values. Instead of having the null values, I am replacing the null values with some value. Okay, so here I have a function called fill NA. So with this function, I am trying to fill 130 wherever I am having null. Okay, wherever I am having the null values. Okay, so in place equal to true, which will affect the original data set. Okay, so that is the thing. So let me work on this function. So here this is my data set .tdata.csv, and then what I am trying to do here, I am trying to fill this calories column alone. Okay, first look at this data set. Yeah, this is my data set, and here one second, before filling this, you can see there are null values available here, 31 and then 40. Let's start with the first row. Okay, so row number 2, then 5, so it goes, there are some places. Okay, now I am trying to execute this function. Okay, df of calories dot fill NA, with 10,000. Okay, so wherever I am having null values, so 10,000 will be filled. Why I have given 10,000 is just to show you uniquely. Okay, actually it should not be the way. You should fill with some reasonable values. Okay, as you can see, this 40th row is filled with 10,000, and then row 2 and 5. Okay, but here look at this, the duration column still having the null values. Okay, the reason is, you can see this coding, I have given only the calories column here, df of calories dot fill NA with 10,000. Okay, if I remove this column and if I execute this, now you can see the output. See, in the duration column also it's filled with 10,000. Okay, and here also it's filled with 10,000. Okay, so if I don't specify any column here, if I give just df dot fill NA, what will happen is it will search for the entire table where is the null values, and it will replace all the null values with 10,000. Okay, so if I specify the column name like this calories, okay, it will search for null values only in that column, then it will replace with the given value 10,000. Okay, so that is the way it works. Okay, now the next one, so that is whatever I shown you is replacing the value with some constant value, like what is that, 10,000 or 130 or 150, whatever it is. Okay, but that is not the reasonable way of filling it. Okay, for example, if there is any value missing in the calories column, okay, you can look at the values in the calories column. Mostly everything is like 200 to 400, around that range only, 200, 300, 400, okay, not beyond that. Okay, so what you can do is, the reasonable way is, you can take the average of that column and you can fill the null values with the average of average value. Okay, so that is one way. The other way is mean is the average. Okay, you can use the median or mode. Okay, take all the values in the column and find out an average and fill the null values, or take the median of all the values and fill it, or take the mode of all the values and fill it. Okay, so there is a formula to calculate the mode, right? Mean, median, mode, all those things. So median is like center value. You can take the range of values, starting and ending values, and what is the middle value that you can take it, that is the median. For mode, there may be some calculation. You can use that calculation, and you don't need to do any calculation. You can just call the function, it will do the work. Okay, so here in this coding, I am trying to find the average. Df of color is dot mean. So this function will give you the average of all the values which is available in the column calories. Okay, so take that value and you fill it here. Df of calories dot fill na with what? X. Okay, X is the average of all the values. Okay, so that is one way. The other ways is you can use median, mode, everything. Okay, I can show you here. Yeah, so this is the function to fill with mode. Okay, so df of calories dot mode of 0. So this will give you the mode value. So you can fill na with the x, then it will fill the mode value. Okay, so that is the logical way of filling the data. You'll have to use mean, median or mode. It is not like some random numbers you can fill it up. Okay, so that is about handling the empty cells. Okay, the second one, handling the wrong format data. Okay, so here when you look at this data, yeah, you look at this second column, date column. It is having some format, date, month, and date. Okay, sorry, year, month, and date. But when you look at this, see here, it is not in the format. But the data is correct, 2020, 12, and 26. But that is not in the format. There is no slash. So because of that, it is not in the date format. Okay. Then here also we have one more data. Okay, so like this, I want to convert all this data into a proper format, a date format. So I can use this function. Okay, so pd dot to date time of which column you are going to convert. So you give the column name, df of date column. Okay, so that data whatever available in the date column will be converted into date time format. Okay, now your output will be like, after doing this, see, I am using this function pd dot to date time. So after doing this, you can check the output here. See, all the dates have been formatted, and instead of slash, it is given hyphen. Okay, 2020, then month, and then the date. Okay, there is no date without format. Okay, so everything has been converted here, you can see. So that is about converting the wrong format of the data. The other one, in the previous, maybe in the session one, we have seen a function like what is that? Converting the object into integer or floating point. That is also one of the example for this format conversion. Okay, only if you convert that object into a numerical data, then you are able to handle the data. Okay, So this is about converting the to correct format. The next one we have is fixing the wrong data. That is the third type. So what is that wrong data means? Wrong format we know. Wrong data is, for example, I'll go to the data, then you may be able to understand here. So look at this data. This one I have filled. Okay, leave about this value. You can see here, this is 440. Usually the duration column is 60, 45 or 30. Mostly these values you will have 30, 45, 60. Duration is nothing but how much time a person is work out per day. Okay, that is doing exercise per day. So maybe 30 minutes, 45 minutes or 1 hour, 60 minutes. Even if it is maybe 2 hours, but not more than that. But when you look at this, you have something called 450. That is not possible. Uh, it shows that there is some error in the data. Okay. So what you are going to do with that kind of data? If there is 1 or 2 values, you can manually do it. Okay, just remove the data and fill with some useful values, maybe average value or some 30, 45 or 60, some data you can fill it up. Okay, but if there are thousands and thousands of columns, thousands of rows, then in that I cannot look at manually where is that 450 or something like that. Okay, so in that case what we are going to do is we are going to run a for loop. Okay, so this first one is the manual way of doing it. A df dot allocation 7 comma duration equal to 45. It means that it will go to the row 7th row and the duration column, and then it will make it as 45. Okay, if you want I'll show you that. So yeah, execute this data. Before that you need to check what is available in the 7th row and 9th row. Seventh row it is 450 and 9th row it's already 60. Okay, so let me try to do this. Okay, so I have replaced only the 7th row with 45 in the duration column. Okay, so let's go and check this 7th row. As you can see here, the 450 has been replaced with 45. So if you want, you just give some other value, 60. So you can see 7th row it becomes 60 now. Okay, so like this you can do it manually for one row. If it is 1 or 2 rows you can do it. Okay, but imagine there are many rows which is having this kind of wrong data. Okay, so in that case what we can do is you can fix up some saturation point, some maximum value. So I am going to check here df dot location of x comma duration. X is the row 1 by 1. Okay, you can see here for x in df dot index. Df is the data frame and df dot index is the index 0, 1, 2, 3, it goes like that. Okay, so df dot location x will be first 0, 0th row, duration column is greater than 120. If it is greater than 120, 120 is 2 hours. Okay, in case if the value which is available in the duration column is more than 120, then what I am trying to do, df dot location of x, the same row of duration equal to make it as 120. if it is more than 120, I will make it as 120. Even if it is 450 or 350 or even if it is 121 also, I will make it as 120. Okay, so I am fixing some maximum value for that column, that is 2 hours, that is 120 minutes. So whatever available value which is more than 120, I will make all the values in that column as 120. Okay, so that's what happening in this for loop, this entire for loop. Okay, that is one thing. Or otherwise, if it is more than 120, what we'll do is drop x comma in place equal to 2. Okay, so drop means you can drop that row wherever I have more than 120, you just simply remove the row. Okay, so that is what the drop function is. Okay, so we'll try to do both functions now. So this is the one which will replace with 120. Okay, if it is more than 120. So what I'll do is now this 7th column I will make it as some 200, then only we can check the output. Okay, if it is more than 120 only we can check. So I'll do this now. So 7th column you can check. 7th column here I have made it as 200. So it becomes 200 now. Now here in the for loop I am checking greater than 120. If it is greater than 120, I am making it as 120. Okay, so that's why wherever it is more than 120, all the values will be changed. Let me check. You can see this is one value 120, that is maybe 450 previously. Okay, so like that wherever we have more than 120, all values has been changed. The next technique I told you is drop the rows. Okay, so I'll execute this for this for loop. Here I am checking greater than or equal to 120. So just drop using this function df.drop. So after executing this, you can see the 7th row is not there. 5, 6, 7 is not there because it is, if it is more than, greater than or equal to 120, that row will be removed. Okay, so like that you can fix any value and you can remove the rows. If it is more than 90, you can remove it. Like that you can do it. Okay, so that is the different ways of dealing with wrong data. Okay, then the fourth category of data is duplicates. Okay, so here there is a function called drop duplicates. With that you can remove the duplicates. And before that, if you want to see where the duplicated data are available, you can use this function duplicated. Okay, so if I give that function, you can see the output here. I have given df.duplicated and .toString is to print all the rows. Okay, see initially it's giving all false, 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 and there is one row called true. So when that row is true, it means that that row is a duplicate of already existing data, existing row. Okay, and you can see the other data are false, false. Okay, and after that you can see from 31 you are getting all true, 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 true. So it means that these all rows are duplicate of the previous rows. Okay, so that is what the meaning of this false and true. Now how do you remove these duplicates? just use this function df dot drop duplicates, execute this. You can see here, see the 12th row is removed, 10, 11, 12 is not there, and similarly only till 30 there is a original data. After 30, 31, 32, 33 everything becomes duplicate of the previous data. Okay, so everything is removed and only 46 and 49 is the very different data, okay, from the previous data. Okay, so that is about removing the duplicates. Okay, just use drop duplicates and bracket you give in place equal to true, then only it will affect the original data set df. Okay, okay. Then there is a function called correlation. Correlation will tell you how each attribute depends on the another attribute. Okay, so there are some attributes given here: duration, pulse, maximum pulse, and calories. Okay, so what is this dependency means? For example, the calories depends upon duration. Okay, so how much calorie you are burned per day depends upon how much time or how much duration you are working out. For example, if I am working out for 30 minutes, I may burn 100 calories. If I work out for 60 minutes, I may burn maybe 200 calories. Okay, so the calories full and fully depends upon the duration column. Okay, so that's why you can see this output here 0.9. Okay, 0.9, these values will be mostly from -1 to 1. Okay, so if it is 1, if it is almost nearing to 1, for example 0.8, 0.91, it means that there is a strong relationship, there is a strong correlation between the two data. Okay, calories to duration. Okay, and if it is maybe -1, there is a reverse correlation between the two data. Okay, for example, if you increase the duration, the calorie burned also will increase. Okay, so that is a direct relationship, so that's why this value is positive 0.9. Okay, if there is a reverse correlation, for example, if you increase the duration, the calorie will decrease. If that kind of relationship is there, then the values will be in negative. Okay, something like this. Okay, so that is the negative value indicates if there is a reverse correlation. Okay, if there is no correlation, the values will be maybe less than 0.5. Okay, something like this, 0.00 and 0.025. These are all, there is no correlation between calories and pulse, that will show you. Okay, so depends upon these values, you can tell me clearly that which column depends upon which column. Okay, so how do you find out this? There is a method called cor. Okay, and df dot cor. Cor means correlation. Okay, so use this here. Why I am removing this date column is the date column is not related to anything. Okay, so that's why I am removing here. So if you execute this, you can see some of these values. Okay, so that is the way you can get your output with the help of a simple function called CORR. Okay, so if your data which is available in the data set is correct, then you will get a correlation matrix correctly. Okay, in case if the data is wrong, then the correlation matrix also will be wrong. Okay, so that's what discussed here. These numbers will vary from -1 to 1. 1 means there is a strong relationship. Okay, perfect correlation. 0.9 also may be good, that is if it is 0.8, 0.9, it is good value. okay, and minus 0.9 would be it is also a good relationship, but what I told you, it's a reverse. If you increase one value, the other value will go down, okay. 0.2, 0.3, maybe the one which is nearing to 0, it shows there is no correlation, okay. And from the table you can understand, see, if you look at this table, you can see the diagonal matrix, the diagonal elements are 1, duration to duration column and pulse to pulse column. And then all this, because the same column is related to same column, there is no point in comparing here, okay. It's same column, so definitely you will get 1, okay. 1 means it's fully correlated, it's fully related, okay. So the diagonal entries you no need to consider, you will have to consider the other entries only, okay. So that is about the correlation function. The next one we have is pandas plotting, okay. So here we are not going to do the plotting using this pandas. We are going to look at plotting using library called matplotlib, okay. So that's what we are going to consider. So I am not going to consider this now, okay. So I'll take a separate session on matplotlib. So in that I will be covering the entire different types of graphs which will be plotting used for the different data sets, okay. Maybe like a scatter plot, line chart, bar chart, and pie chart, okay. There are variety of graphs available. The library for that is a matplotlib. So that is the library especially for plotting different types of graphs, okay. So in that session we will be exploring more on graphs, okay. So today I will start with this pandas library. Then in the next session we will be looking at matplotlib library in detail, okay, which is for plotting different kinds of graphs, okay. Thank you.